Okay, this is your homework help video for 4-5, Classwork, Linear Inequalities. This was classwork, so if you're watching this video, it probably means you were absent. We did all of these together in class. Now what I'm going to do on the video is I'm going to focus on doing this as much as possible in the calculator. Okay? So there are ways to do all this by hand, and we did that in class, and we'll also show you that more in class. But on the video, I'm just going to take time to show you how you can actually put this in the calculator. So the first several questions says graph each linear inequality. Okay, inequality means it's not just a line, and the line is actually referred to as a boundary line. The line itself may or may not be part of the solution. If you have the equal part under your greater than or less than, the line is part of the solution. Okay, we'll get into that as we did number 1. So number 1 says x is greater than or equal to -7. I can go to my graph screen, and I want to graph x equals -7. That's not going to happen with my screen the way it is. So what I do is I hit delete, and I delete the equal sign, and I go down to number 6. I can pretty much graph everything however I want to by doing it that way, okay? So delete and then number 6 can get me to graphing a relation. So I'm going to type in x. Now how do I get to this greater than or equal to? If you look at your equal sign, look at the stuff right above it in yellow. You have some other options. If I push Control equal, that pulls up those options. And I want to use greater than or equal to. So I go down to greater than or equal to, push this button right here in the middle, and that puts it on the screen for me. And then this is not a minus. It looks like a minus on the paper, but that is a negative sign because it's right in front of a term. There's nothing on the other side, no terms on the other side. So I put -7, and there I go. I push enter. That is my graph. Notice that is a vertical line. Sorry for the glare there on the calculator. I'm going to get rid of the calculator now that we saw it. That is a glare, and we'll try to work around that glare. Okay, so I'll hold it sideways so you don't see the glare. See how that shading is all to the right. Now let's explain what that means. The vertical line is because whenever you have x equals something or x is greater than something, you're dealing with an undefined slope. It's one of those special cases. A zero slope is horizontal. This is an undefined slope. It's straight up and down. And where does it cross the x-axis? At -7. So what you did here is you counted 7 to the left. That's what we're going to do here on the paper. Here is 5, 6, 7. And it's a straight up and down line. Since we have the equal to part on there, this is a solid line. Now the calculator does show solid versus dotted, but sometimes it's really hard to see and tell the difference on the calculator screen. So the best practice is just to remember, if you have the line underneath your inequality, it's solid, the graph is solid. If you don't have that little line, it's going to be dotted. Okay? So all of this stuff is shaded. That's it. Let's head to number 3. Y is greater than or equal to 2 plus x. So I'm going to go here, I'm going to go back to graph, and I'm going to type it in. I'm going to go ahead and delete the equal sign, go down to 6, and put in y is greater than or equal to 2 plus x. Y, I hit Control, equal sign, and I go to greater than or equal 2 plus x. 2 plus x. There it is on the screen. I push enter. There's my line. Now you can get a good graph if you need the calculator to do it. Find your intercepts. That's 2 to the left and that's 2 up. Those are my intercepts, and I can get my graph based on that. It's going to be a solid line because of the solid line on my inequality. Okay, it looks like my pattern is, I'm going to follow my pattern the way it's written. Doesn't ask me to find the slope, so I don't have to worry about finding the numerical value. I'm just going to go by the pattern. You could also use a straight edge. Since the equal part is there, it's a solid line. And greater than makes you shade above. Here's all the shading above, because that's what greater than means. There's my shading for number 3. Let's go ahead and do number 5 together. Okay, x minus y is greater than or equal to 8. So I'm going to try to hide that glare. There we go. I'm going to go to my graph screen. Here we go. And I'm going to go to delete 6 to get to that relation graph screen. X minus y. I'm putting x, subtract y, and then I hit control equal. I'm going to put greater than or equal again. 8. Push enter. There it is. Let's find those intercepts. This one, and I'm just going to use the calculator screen. I'm showing you guys that you can do this if you need to on the calculator. I'm counting over 1, 2, 3, 4, 5, 6, 7, 8 to the right. That is my x-intercept. Okay? You know what? I miscounted. There it is right there. Okay, now the y-intercept is a little bit off the screen. Do you guys remember how you can drag down? I'm going to show you. I'm going to go over here to somewhere where there's nothing there. I'm going to click and hold. Becomes a little grippy hand, and I'm going to drag and drag down like that so I can see that y-intercept. And now I can count that thing. Okay, starting here. How many count? Oh, and you know what? I'm going to remind you guys, you can go to menu, view, and you can turn on your grid lines. Just go through menu, view. You're changing how you view it. You don't have to always memorize the numbers. You can just go, it's intuitive on the menu, where to go by the menu. Count my grid. 1, 2, 3, 4, 5, 6, 7. That's -8. So it was 8 this way, and it was also -8. So 8 down. Now I can make my line, and it's got the equal part, so it's going to be solid again. And the shading is below because it's, here's why. It looks like greater than here, right? So you're thinking, oh, why don't I shade above? When you do this by hand, you divide by that -1. Whenever you divide by a negative, you have to flip the inequality. So this is not a mistake on the calculator screen. They did all that work for you, and they did shade it correctly. Okay, let's go ahead and do some of these down here. We'll do 7, 9, and 11. These you can also do on the calculator. It says, determine whether the ordered pair is a solution of the linear inequality. So let me demonstrate what they're saying here. Here's the inequality. Then they have this semicolon, and they have an ordered pair over here to the side. They're giving you an x and y value. They're basically saying, if I plug the -3 here for x, and I plug in the -1 here for y, is this going to come out to be a true statement? If it does, then it is part of the solution. If it does not, if this side really is not greater than this side, then it's going to be a false statement. I'm going to show you 2 ways to do these. The first way will be on the calculate screen. We're going to type in this inequality, but instead of x and y, we're going to type in the numbers they gave us. So let me demonstrate on paper. Instead of 4x, I'm going to put 4 parentheses. And instead of 3y, I'm going to put 3 parentheses. And where I see those parentheses, I'm going to put a number in those parentheses on the calculator screen. So I'm going to type in 4, and I'm going to put parentheses, and I'm plugging in -3 for that x value. Plus 3, and then parentheses, and I'm going to type in -1 for that y value. You see what I'm doing? And now I'm going to put in my greater than sign, doing control divide, greater than -2. I push enter, it says false. That means this point is actually not part of the solution. Meaning if I graph this thing, this point is not going to be in the shaded area. The shaded area is where the solutions are. And if it had happened to have the equal part on there, the line would count as a solution too. But this one doesn't have that. So this is not part of the shaded area of this graph. Let's do number 9. I'm going to show you the same way, and then number 11 we'll do a different way. So number 9, we have y minus 4x equals 0. I'm not going to put y, I'm going to put 4, because that is the y value they gave me. So 4 minus 4, and I'm going to put the 1 here for x, less than or equal to 0. So in the calculator screen, 4 minus 4, and I'm going to put times 1 in parentheses, and then control equal less than or equal to 0. That one came out as true, meaning that point does lie in the solution. It's either in the shaded area or it's on the line in this case because of the equal sign. The line is part of your solution. So this is true. So you can say yes or true. Now number 11, I'm going to show you a different way you can do these same problems. Y is less than or equal to 2x minus 3. Here's what I'm going to do. I'm going to actually go to the graph screen. And there's my y equals. It already says y equals. But I don't want equals. I want less than or equal. So I'm going to delete, and I go to less than or equal. There you go. So now it went ahead and went to the relation screen. And you could also just go straight to the relation screen and type the whole thing in also. Y is less than or equal to 2x. I'm not going to plug in numbers this time. 2x minus 3. This is just another option for you guys. This gives me the graph with the shading. So if I turn on my grid by going to Menu, View, Grid, and show the line grid, there's all my boxes. I could plot this point, even just with my pencil, just pointing to the calculator screen. 1 to the left and 4 down. 1 to the left and 1, 2, 3, 4 down. It's very close, but that is not in the shaded area. You see that? 1 to the left and 4 down. It is not, it's close, but it's not in the shaded area. And it's very obvious that it's not. That's another visual way to be able to look and see, is the point physically in the shaded area? Even if it had been on the line, if it was on the line, it would be okay because we have the equal sign underneath there. But it's not on the line, it's not in the shaded area. That's a false. Okay, let's head over to the back. We're going to do a few on the back. 13. When we did this in class, we actually changed the numbers to make it a little more approachable. Okay, so I'm going to go and change these numbers the way we did in class. The x-axis, I'm going to renumber one. Each box is worth one value, so they're just going by ones. Now the y value is actually going, the y-axis, if you look, every 2 boxes is worth 3. That means every box is worth 1.5 or 1.5. So just keep that in mind. Okay, so they want to know my b value. We know the b as the y-intercept. Where is it? It's right here, and that's -6, isn't it? The slope is my down and right, down and right. We can tell by looking at the line it's negative, it's going downhill. So my counts are down and right, down and right. I'm going down 2 boxes and 1 to the right. Down 2 boxes and 1 to the right. But it's not -2. I have to pay attention to the value of what two squares is. It's actually 3. So it's actually, each 2 boxes is 3. So I'm really going down 3, 1 to the right. Down 3, 1 to the right. My slope is -3. We can agree that the shading is below. By looking at this graph, I can tell by putting my pencil anywhere on the line itself and drawing straight down. I'm going into the shaded area. Anywhere on the line, when I draw straight down, it's into the shaded area. That's considered below. And straight up is considered above, and that is not shaded. The line is solid. Okay, since the line is solid, we know that we're dealing with the equal sign underneath our inequality. So it's one of these. Since the shading is below, we know it is less than. So we are dealing with less than or equal to. So from this point, in my mind, I can be thinking in my mind y equals mx plus b, because that's the pattern I know, and I have my m and my b. But I'm not going to write the equal sign. I'm writing less than or equal. So y is less than or equal to -3x minus 6. That's my slope. That's my y-intercept. One more that we're doing together. Actually, we're not, because I'm out of time. we will cover this one in class if you have questions.